Good day everyone, good day viewers. In today's topic, we are going to discuss three, three topics which are: first, length of the curves. Second is surface area, and lastly is centroids. So first we are going to discuss length of the curve. So let's do that here. So length of the curve. So if we say we have a line here, this is our y-axis and this is our x. Let's say we have a curve here. This is bounded by point A, and let's say this is bounded by point B. Say we have this here, and this curve is equals to y of f of x. Now let's say here we will make a strip here. Can you see it there? It's color blue, and this strip here is our DL, or differential length. Now we have to make a Pythagorean or triangle here. Say this. Let's erase this first. So this is bounded here. So we put it here, and this is, let's say that's a triangle, and this area is called our dy, and this area is called our dx. From the origin here, this is 0, origin x, and the height of this of this strip is y. Now if we take out this strip here, let's put it here, this will look like this. DL is DL, differential length, is our dy, and this is our dx. So if we say this is equals to DL squared equals to dx squared plus dy squared, our differential length here, if this equation is divided by dx squared, this will become dl over dx squared equals to dx squared, and dx squared will just become 1 plus dy over dx squared. So guys, do you remember dy over dx? Yes, that is called our a derivative, or our y prime. Let's rename this as y prime. Now here, if we divided both sides by dx, this will become dl over dx, no, dl equals to dx squared. So this will become, if we divided both sides by dx squared, say dx squared, this will become dl is equals to the square root, oh no, I mean if we transfer first dx in the other side, this will become dl squared 1 equals to 1 plus dy over dx. Let's just rename this as y prime. So y prime squared dx. Now if we square both of these to cancel dl squared and square root, this will become dl is equals to square root of 1 plus y prime squared dx. Now if we are to get the differential length here, this will become L is equals to the integral of square root of 1 plus y prime squared dx. And this is our formula for length of the curve. Now let's move on to some examples. So example number 1 here. So let's say in our example number 1, find the length of the curve y equals to square root of x from x equals to 0 to x equals to 4. Let's say we illustrate. So this is our y, this is our x, bounded from x to 0, and let's say this is 4. So we all know the curve here y equals to square root of x will look like this, right? So this is bounded from this point 4. Now we are going to make a strip here. Let's say we put it here. Can you see it? It's right here. And say this is dl, this is our dy, and this is our dx. The height of this is just equals to y, and the origin, from the origin to our point, our strip here, this is our x. So let's transfer here our strip. This is dl, this is dy, and this is dx. So as we're calling as our formula, this curve here is equals to y of square root of x. So now we are going first to find the y prime. Oh no, wait, we need to derive the formula from here. So as I mentioned earlier, our formula looks like this. L equals to the integral of from limits to 0 to 4. Let's put that 0 to 4, and square root of 1 plus y prime here. The derivative of square root of x is just y prime is equals to 1 over 2 square root of x. So let's put that here, 1 over 2 square root of x. Don't forget the squared here, okay, dx. So L is equals to by solving this using our calculator, our answer, let me input my calculator here. Can you see it? Yeah, okay. So the integral of 4, you see, let's just follow my voice, okay? With input the integral of 4 from limit to 0 to 4, and the square root of 1 plus the derivative of y equals to square root of x is just 1 over 2 square root of x dx. And don't forget the squared, guys, here, squared. Can you see the square here? So our answer should be, let's wait for my calculator. So guys, if you wonder when you put it, you input here from limits 4 to 0 and it equals to math error, because here, can you see it? because if you divide a number by 0, it becomes undefined. So let's say if we put something close to 0, let's say here I put 0.001, 0.001 here, and an answer is something like 4.86, I think. Let's wait our calculator to load. So our answer here is not 4.86 but 4.63. And see guys, my calculator, it's 4.63. So 4.63, and let's say 4.63 units, because this is just the length of our curve. So this is our answer for our problem number 1. Let's move on to problem number 2. So this is our problem number 2. Find the length of the curve y equals to x squared plus 2 from x equals to 0 to x equals to 5. So first we need to illustrate, say here. So y equals to x squared plus 2 is a parabola. So guys, reminding you how to get the points of intersection here. First we differentiate this. So y prime of this is just equals to 2x, and if we equate x to 0, our y will be 2. So this is our vertex from 0, x0, and let's say this is 2. So let's put here our vertex here. Can you see it here? Vertex. This is our point of vertex. Now we need to find the points here. Let's say we have, if x equals to, and this is x and y, if x equals to 0, this is 2. Let's say we have here negative 2 and 2, and this is 2. Negative 2 raised to 2. Our y should be, it's not 2. So 2 raised to 2 is 4, plus 2 is 6. Now it's also 6. So our the points of our parabola is from negative 2, but we don't mind that. We only mind this right side here, this part here. Okay, so if x equals to 2, and let's say this is 6, no, or y equals to 6, it is 6. Our parabola should look like this. Oh no, it's not straight. It should look like this. Okay, so bounded from x equals to 5 from this point. Let me make it bigger here. Let's say this is 2. Oh no, let's change here our x. If x equals to 2. So our point here, this is, let's say this is 2. So this is our area that we need to solve. Now if we put here a strip here, let's say this strip, and this is our dl, this is our dy, and this is our dx. So the height of this strip from our strip to the x-axis is just equals to y, and from this point is just equals to x. Now let's take out the strip here. Let me erase this. So this is our dl, or our differential length. This is dy, and this is our dx. So the length here, is equals to the integral of square root of 1 plus what is the prime y prime of x squared plus 2. Yes, that's correct. Here it's already written because this is used to find our vertex. So let's say 2x, so 2x squared dx from limits to 0 to 2. Now we are ready to integrate this problem. So let's cancel first no, we need to square root first our equation. So square root of 1, just a wrong pen. So from limits to 0 to 2, so the integral of the square root of 1 just equals to 1 plus, let's say if we distribute this here, that is 4x squared. So the square root of 4x squared is just 2x. So 2 here, so an easy way, 2 here and square root here, we just cancel each other out, dx. Now we are ready to integrate this problem. So the integral of 1 is just equals to x plus the integral of 2x is just equals to just equals to 2x squared. So 2, let's bring out 2, and this is x squared over 2. 2 and 2 here, we just cancel each other out. From limits bounded by the limits of 0 to 2. So by simplifying this even further, x plus x squared from limits to 0 to 2. Now we distribute here the value of 2 to each of these x's. So 2 plus 2 raised to 2 minus 0 here raised to 0 is just equals to 0. So our final answer must be 2 plus 2 square root of 2 is 4, so 4 plus 2 is just 6. So 6 units. So this is our answer for problem number 2 under length of the curves. Now we are going to discuss surface area. So let's put here surface area. Surface area here. So first we need to illustrate. Let's say this is our y-axis and this is our x-axis bounded by the curve here. Let's say it's bounded from the point A here to the point B here. So this is bounded B. Let me erase this. It's a broken line. Erase this first. So it's bounded from point A to B. Let's say we put our strip here. Strip here. Let me change my color here. Strip here. So wait, let me first do this again. So if our area is bounded by here a line and bounded from point A to B, and this, let's say here we put a strip here, this is our DL, same as last time in doing the length of the curve. This is DL, this is our DL here, and the height of the strip here, let's say here the height of this strip is RY, and the point here from our strip to the origin is just called X. Now if our strip here is rotated, so this will be look like this circle. is rotated from this point to this point, this will look like a shell, right? Or a solid disk. Now if we take this disc out here, let's say here, let's erase this first. So if we take this disc out, this is our DL, let's say this is our DL, this is our DL, and bounded by the curve. Here, let me draw a circle. Let's say this is a perfect circle. so this is our DL here, and this, the height of this circle from our strip to our x-axis is just called y. Now if we cut this solid shape, this will look like this. This will look like this. So this is our DL, and the circumference of the circle is just 2 pi r. Ry here is a radius, so 2 pi r. Instead of r, we put y because that's our radius. Y is our radius, and this strip is our DSA, or our differential surface area. So by deriving this, DSA is equals to 2 pi y DL. As you guys remembered, our DL here in the length of the curve is just equals to, let me simplify this further, DSA is equals to 2 pi y. DL here is the square root of 1 plus y prime dx. Alright? Now, if we integrate this, our surface area is equals to the integral of 2 pi y square root of 1 minus, no, it's not minus, it's plus, I mean, sorry for that, it's plus y prime. Y prime here is just a different, it's just a derivative of our y. Okay, so dx bound from limits to a to b. So this is S. So this is our formula for our surface area. Now let's move on to some examples. Let me give you 2 examples here. So let's say one here. So let's say here, number 1 example, find the surface area of a line x plus y is equals to 5 from x equals to 0 to x equals to 5. Now first thing we need to do here is very important, is to illustrate. Say that this is our y-axis and this is our x-axis. Bounded from x, let's say this is 5. Now, how do we get x here? So if x, so if we cover this, and see my finger, let's say we cover this. So if we cover y, our x will become 5. So this from this point here, let me see it, from this point here, this is our x. Now if we covered y, if we cover now x, if we equate x to 0, our y will become, can you see it? Our y becomes 5. So let's put 5 here. Let's say this is 5. Now we have a line here. Say that it's a perfect line. Now we have a line here. Now we are ready to illustrate. So if I put here my strip here, let's say that is my strip, this is DL, and rotated, I forgot, rotated about the x-axis. Okay, so this is our area of rotation. So let's label our illustration. So from this point to this point, this is our x. Now if it's rotated here, this will look like this, and the height of our strip here to this point is just equals to y, and the height of our point here 5 to our axis here in x-axis is just equals to 5. So y here, by remembering the formula for this method, I think the bigger height minus the lower height. So let's say y here is just equals to 5 minus y. Now if we take out this strip here, this will let me show you something more simple here. So this, let's say this is my vertical, this is my strip here, and from the point of this, from this point to this point in our x-axis, this is 5. Let me name this as our DL here, DL, and let's say this from this point to this point, this is our y. So our y here, our radius is 5 minus y. So by putting this here, our differential surface area is equals to 2 pi y square root of 1 plus not square root, 1 plus y prime squared dx. So by simplifying this even further, 2 pi y here is just 5 minus y with respect to dx, so this is wrong. Actually our graph here will not be 5 minus y because its area of rotation is from the x-axis. So from this point to our strip here, this is x, and from the origin to our point here, this is 5. So our y here is just equals to 5 minus x, not y, because with respect to dx. Okay, so square root of 1 plus our y prime here let's say if we put our y here is equals to x equals to 5, our line is just equals to -1. Right, that's correct. 1 plus okay, that's -1 squared dx. Can you see? So the integral over surface area here is equals to the integral of 2 pi, our y here is 5 minus x, times the square root of 1 plus -1 squared dx from limits to 0 to 5, because the area of rotation is from the x-axis. So let's solve this. Surface area is equals, let me put it here, to use the space here. Surface area is equals to integral of 5 on 2 pi. Let's put 2 pi outside because that is constant. 2 pi, the integral of, what will be left here is just 5 minus x times the square root of 1 plus negative 1 squared dx. So by limits to from 0 to 5, so by simplifying this, 2 pi times the integral of 5 here is just x, right? X minus x squared over 2 times square root of 1 is just 1, so the integral of 1 is just x plus negative 2 here, we just cancel each other out. So but first we need to 1, so 1 squared, negative 1 raised to 2 is just positive 1, so x equal plus x, this will become 2x. Let's simplify this, 2x. By limits to, from limits bounded by the limits 0 to 5, and let's simplify this even further. 2 pi times, let's say this is 2x squared minus, so 2x cubed over 2, which is 2 and 2 will just cancel out, so this will become x cubed from bounded by limits to 5 to 0, so this is 2 pi times 2, substitute 5 to x, this will become 5 squared minus 5 cubed minus 0. So our answer here will be 2 pi times 5 raised to 5 squared is 25 times 2 is 50. 50 minus, so 5 cubed is just 5 raised to 3 is just 125. So 50 minus 125. So by solving this in our calculator, let's say 2 pi times 50 minus 125, our answer will become negative 150 pi, 150 pi squared units. This pi squared units. So this is our answer for problem number 1 under surface area. Let's move on to problem number 2. So our number 2 problem is find the surface area of the curve y equals to square root of x from x equals to 0 to x equals to 5 rotated about the x-axis. Now first thing we need to do here is to illustrate. This is y-axis, this is our x-axis, and this is our area of rotation. Area of rotation, AOR. So bounded by the curve y equals to square root of x. So square root of x is just, will look like this, right? Okay, so bounded from x equals to 0, let's say this is x equals to 5, so this is bounded by this area right here, and we need to make a strip here. So our strip here is our DL, and it's rotated about the x-axis, so this should look like this. Forgive my drawing here. So from this point here, this is our x, and from this point here is our 5, and the dx of that is equals to 5, so the y of that is equals to 5 minus x, and this is our y. So let me erase this. So by moving this here, this should look like this. Go back. It should look like this. So this is our DL here. This is our DL bounded from y. So this is our 2 pi y, 2 pi y. So let's form our formula. So dsa is equals to 2 pi y dl. So 2 pi y here is just equals to 5 minus x, because area of rotation is in the x-axis. So 5 minus x, dl just square root of 1 minus, let's say this is not 5 but this is 3, forgive me, this is 3, so this is 3, so 3 minus x, 3 minus x. Now 2 pi times 3 minus x, 1 minus y prime here. Y prime of square root of x is just equals to let me get my notes here. So, the y prime of x is just equals to 1 over 2. Let me change my pen. 1 minus 1 over 2 squared of x squared dx. Let's move it here so we can maximize the space. So the integral of that is just equals to surface area equals to the integral of 2 pi 3 minus x times square root of 1 minus 1/2 x squared of x squared dx. Now from limits to 0 to 3. So by putting this in our calculator, our answer should be square root of, from limits to 0 to 3, the integral of 2 pi times 3 minus x square root of 1 minus 1 over 2 square root of x, the square root of x here squared. So guys, as I mentioned earlier, if you have a denominator that is about to change with the value of 0, it is undefined. So let's change 0 here to a closer value to 0, which is just 0.0001. So 0.0001. Now wait, square root of 2. So by by putting this into our calculator, our answer should be, so our answer is 37.01. So 37.01 square units. This is our answer for our problem number 2 under surface area. Now we move on to our last topic for today, which is centroids. So centroids, let's put centroids here. Centroids. So centroids. So let's say in our number 2 example, find the surface area under the curve y equals to x squared plus 2 from x equals to 0 to x equals to 2. So our y here is just a parabola, but we are only concerned in this part of the area. So by formulating, so first we need to find the vertex of our parabola here. So x squared plus 2. Oh wait, we need to differentiate our y here. So the derivative of x squared plus 2 is just equals to 2x. So now if our x is 0, our y will become 2, I mean. So from 0 to 2, let's say this is 2, and bounded from point to 0 to 2. Let's say this is our parabola. Alright, so this is bounded from point 0 to 2, and we make now a vertical strip. Let's put it here, a vertical strip. Can you see it here? Okay, that's good. So our vertical strip here, okay, so if we label this is our x, and the thickness of our vertical strip is just equals to dx, and the height of our vertical strip is just equals to y. And if we say this is our center here, this is our centroid. So from our origin here, from the y-axis to the point to our centroid, this is xc, and from this center until the x-axis, this is our yc. So by putting this outside, this is our, let's say, no, it's too thick. Let's say this is our vertical strip, and this is our dx, and this is our y, and from the center of this vertical strip, this is our yc. Now yc here is just equals to the integral of yc, which is equals to 1/2. Let's put here 1/2 times y dx over the integral of y dx from limits to a to b, from a to b. Now we substitute here our y. So yc here is just the integral of 1/2, and our y here is just equals to x squared plus 2, right? Then dx from limits to 0 to 2 over y dx. Our y here is just equals to x squared, the integral over the integral of x squared plus 2 dx from limits to 0 to 2. Now we are ready to integrate this problem. So this is just equals to, let's put 1/2 outside since that is a constant, and times the derivative of this equation. So the integral of x squared is just equals to x cubed over 3, and the integral of 2 is just 2x from limits to 2 and 0 over the integral of x squared plus 2 is just the same as our numerator here, which is equals to x cubed over 3 plus 2x, and from the limits from 2 to 0. Now our answer, by calculating this into my calculator, we get my calculator here, 1/2 times 2 raised to 3 over 3 plus 2 times 2 over x cubed, say x cubed, 2 cubes, 2 cubed over 3 plus 2 times 2. So our answer here is just equals to, let me first we need to put 1/2 here times x cubed, 2 cubed over 3, so 2 raised to 3 over 3 plus 2 times 2 is equals to 20 thirds, 20 over 3 over 20 over 3. This will just equals to, so this will become just 20 over 3 here, we just cancel each other out, so this will become 1/2. Let's put here a final answer here, 1/2, and see it, 1/2 square units. So that's it for today's lecture, and this is it for our final masterclass video. Thank you guys for listening, and see you again sometime. So let's talk about centroids here. So what comes to mind when you say the word centroid? So for me, centroids, the meaning of centroids is the center. So centroids here is the center of our area. Let me illustrate here first. Let's say there's the curve here, and it's bounded from point A to B, and let's say this is our strip here. Let's make a vertical strip, and this is our strip. So from this point here, this is our X, and let's say then this here is our Y now, and this is our dx. Let's say if our center here is here, can you see it, the red mark? This is our center or centroid. So from this point here, label it, from this point here, this is our YC. YC is just the half of Y, so this is equals to YC equals to Y over 2. And from this point here, our origin, from the point origin 0, from our centroid here, can you see it, centroid, this is our XC. Now by putting this here, so this is our, so let me label this as, this is our Y, the height of our strip. This is dx, the thickness. our strip, and from the center here, this is just yc, and yc is just equals to the half of y, which is y over 2. Okay, now if we are about to derive this formula, this illustration to our formula, this will become, let's put it here, yc is equals to yc here, integral of yc is just equals to y over 2, or let's say 1/2, is 1/2 integral of 1/2 y dx over the integral of y dx from limits to from a to b, and from limits here from a also to b. So this is our formula for our centroid under yc. This is our formula under centroids. So now let's move on to an example here. Let me find one problem. So this problem number 1. So let's say here 1. Find the centroid under the line y equals to x plus 2 from x equals to 0 to x equals to 2. Let's illustrate first. So how to find line here? It's simple. It's just by using tabular method. If x equals to 0, our y is equals to 0. If x equals to 1, our y here becomes 3. So let's input this value. So x here is our y, this is our x axis. So if x equals to 0, this is 2. And if x equals to 1, our line is 3. Our y is 3. So from 0 to 1, 0 to 2, and from 1 to 3. And this is our 2 here. So our illustration should look like this. So it's bounded by this from 0 to 2. So if we have here our strip here, let's put our strip here. This is our vertical strip, and center from this point to this point, this is our x, and the thickness of this is just equals to dx, and the height of our strip is just equals to y. Now if our centroid is located in the center, let's say this is our center, from this point to centroids to our x here, x axis, this is yc, or yc equals to 1/2. Let's say that, and xc here is just equals to our x. Sorry, you cannot see that. So xc here is equals to our x, and from this point, the center to our x-axis is our yc, or the half of our y. Now let's put the strip here outside. Let's put it outside here. So this is our y. Let's say this is our y, and this is our center here. This is just equals to yc, or 1/2, and this is our dx. So by using our formula here, yc is equals to the integral of 1/2. Yc is 1/2, so 1/2 y dx over the integral of y dx from limits to a and b. Now let's substitute the values of y here. So our y here is just equals to x plus 2. let's put it here. Yc is equals to integral of 1 half y dx is just y here is x plus 2 dx over the integral of, it's not a and b, this is from limits to 0 to 2, 0 to 2. Y dx here is just equals to x plus 2 dx. Now we have now our illustrated or form our solution here. So let's do that. Let's integrate. So taking 1 half outside, since 1 half is constant, and the integral of x here is just equals to x squared over 2 plus 2 here. 2 here is just equals to x. From limits to 2 and 0 over x here will just become x plus 2, x here become x squared over 2 plus x, from limits also to 0 to 2. So now by finalizing this, let me get my calculator. So you substitute x here to R2. So let's do that. Let me get my calculator here. So 1 half, no, let's take out 1 half here, 1 half, and let's just solve x squared over 2 plus x over this part. Okay, so by substituting x to 2, this become 2 over 2. So by putting this into my calculator, our answer here will be 1 half times 1 is just equals to 1 half square units, and this is our answer for our problem number 1 under Centroid. Let's move on to our last example in number 2 here under Centroids. So for our number 2 problem, find the surface area under the curve y equals to x squared plus 2 from x equals to 0 to x equals to 2. Now here we know that this is a parabola opening upward, so but first we need to find its vertex. So let's do that. Let's just differentiate this equation, that with the y prime is just 2x, and if we equate x to 0, our y will become 2. So let's say this is 0 and this is 2. So our point of vertex is here. Now let's say if our parabola is opening is upward, let's say this is our x here is 2, and this is the area, surface area that we need to find. Now if we put a vertical strip here, let's name this as, this is, you see it, okay, there. Let's name this as x first. This is x, and the height of this vertical strip is just equals to y. And when here, this is our center, this is what this is called yc. This is just 1 half of y, and this is xc. Now if we move this here, this will become this, our vertical strip. This is y, and this is dx. I forgot to put here dx because dx here is just a thickness of our vertical strip. And our center here is our centroid, and this is called yc. Now by putting in our formula here, yc is just equals the integral of YC here is 1/2, so 1/2 1/2 times y dx over forgot the limit of here is a to b over the integral of y dx, which limits from a to b. Now if we put it here, let's put it here, yc is just equals to, now I will substitute the values. So y here is just x squared, which is y equals x squared plus 2. So the integral of 1/2 y here is just x squared times plus 2 dx from limits to 0 to 2, 0 to 2, okay, over the integral of y dx, which is our y dx is just equals to x squared plus 2 dx from limits also from 0 to 2. Now let's integrate this. Let's put 1/2 outside because since it is a constant, and integrate this equation. So by using mental integration, x squared here will become x cubed over 3 plus 2x over from limits to 0 to 2 over the same, this is same, x cubed over 3 plus 2x from limits to 0 to 2. Now we are ready to substitute here the value of 2 here and 2 and 2 here. Now by calculating this into my calculator, my answer will be, since 2/3 here, 2 raised to 8, let's just put it here, x cubed, this will become 8/3 plus 2 times 2 is just 4. So this is 4 over, since it is same, this is over 8/3 plus 4. So 8/3 plus 4 and 8/3 plus 4 we just cancel each other out, and our answer will be 1/2 squared units. So that's all for centroids, and that's all for the topics that we discussed today. So feel free to like my video, don't forget to subscribe, and have a good day everyone. Thank you for listening.